Hello everyone from Math 1435. It's Pre-Calculus 2. Me, Professor Wenson here again with a video on your KnewtonAlta homework, section 8.1, part 2. It's titled Transformations of Sine and Cosine Graphs. So we saw in 8.1 part 1 how to graph, f of x equals sine of x and f of x equals cosine of x, right, the plane sine and cosine functions, and we saw some properties of them. Here we're going to be taking the graphs of sine of x, cosine of x, and transforming them by introducing new numbers, say multiplying the function by a number, or adding a number to a function, or replacing x with 2x or something like that. And hopefully this is a bit of a refresher to when you transformed graphs of functions in Pre-Calculus 1. All that stuff is coming back. Alright, so here I am in section 8.1 part 2. There are several, I think there are 3 objectives. Let me see. No, there are only 2 objectives. This one I'm currently on is determine the period and amplitude of a sinusoidal function. Sinusoidal just means a wave. Alright, sinusoidal just means it's a version of the sine function or the cosine function. Alright, so I know it starts with sine here, but sinusoidal simply means sine or cosine, some sort of sine or cosine wave. Alright, so I'm actually going to get into, go to paper here and talk about amplitude and period. Alright. Now the word period did come up in section 8.1 part 1. Let me just show you again here, refresh your memory. What did the graph of the sine function look like? Plain old sine of x. And I'll draw a couple different, a couple repetitions, a couple cycles. So if you recall, remember the period. The period is, after how many units will the graph repeat itself, right? This is the number of units until graph repeats. And this isn't a very technical definition, but it's a way you can think about the period of a graph. The amplitude is going to be the height of the wave. The height of the wave, right? Because again, all these sine graphs and cosine graphs are waves. So one period was, for the sine function was 2 pi, right? It repeated every 2 pi. So 0 to 2 pi, then say 0 to negative 2 pi. This would be 2 of these periods, right? And the largest it got was 1. The smallest value of sine was -1. The lowest it got was -1. And then, if I just draw a notch here every 90 degrees, every pi over 2 radians, so pi over 2, pi, 3 pi over 2, and 2 pi, the graph of one cycle of the sine function looked like this. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 was -1. And the sine of 2 pi is 0 again. And you had all these other special angles in between, but you could figure those. You could look at those. Go back to section 8.1 part 1 again. Then you just kind of traced out the wave. All right. So here is one repetition, one cycle of this sine wave. And I could draw it again over here, right? And then it's just going to be the same picture copied over here. So again, I break this up. Let's from 0 to negative 2 pi. That's another period. I'll break this up into quarters. Go every pi over 2. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then just following the pattern, drawing the same picture again. The sine of negative pi over 2 is negative 1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is positive 1. And the sine of negative 2 pi is 0. And you get, again, the same picture again. It's just another copy. All right. So here's a picture of two cycles, two repetitions of the same sine wave, the same graph. And this would go on forever that way, and forever that way. Right? Just keep on going up and down and up and down. So this was the sine wave, and the cosine wave was similar. I'm not going to draw that right now. What I want to talk about are again the amplitude and the period. So the period, remember, was 2 pi. Right? For the period was just how often does this thing repeat? It repeats every 2 pi radians. Right. Now the amplitude is, as I mentioned, the height of the wave. So it's from the middle of the wave. Right. So here the x-axis is going to be referred to as the midline. Right. Here it's y equals 0, the x-axis. So it's the distance from the midline to the top of the wave, or from the midline to the bottom of the wave. But it's a positive quantity. Right? It is not. You're not going to have any negative amplitude. So this distance right here, from the top of the wave to the midline. All right, that's kind of faint. Throw that marker away. That's called, again, the amplitude. Let me redo this here. There we go. This distance, this is the amplitude. And what is that distance? Right. Well, I'm going from y equals 0 to y equals 1. So the amplitude of the sine wave here is 1 unit. Right. And you could also figure that out from here. Remember I said it's from the midline to the top, or from the midline to the bottom. Right. Again, what is that distance? Right. Again, amplitude is 1 unit. Right. Even though I'm going down, amplitude is like a distance, a height. You don't have negative height. All right. So amplitude is never negative. Same thing for period. Period is not a negative number. Okay, when you're asked for the amplitude that's greater than 0, when you're asked for the period of a function that's also greater than 0. Okay, you shouldn't be answering a negative number. All right, now let's see what happens when I change this rule for the function a little bit. Right now I have 1 times the sine of 1x, right? This is the same thing as 1 times the sine of 1x, right? When I have just the sine of x. And where I put these 1s is going to be important for determining the amplitude of a wave, a cosine or a sine, and the period. So let me show you some pictures. Alright, now I'm going to go to, this is the desmos.com. It's a free online graphing calculator. And the only reason I'm bringing this up is because it's faster than my TI. Alright, so let me put in, y equals the sine of x. And I can use different colors and stuff here too. Right, so here's the sine wave. Alright, now notice when I zoom in here. Alright, remember the height, see that pi over 2, 1, and the midline is at 0. Right. The amplitude's 1 at the moment. Right. Now that's in red. Now what if I multiply this function, this sine x rule, on the outside by some number like 2? y equals 2 times the sine of x. Look at what happens. See how the midline doesn't change. The midline does not change. It's still at the x-axis here, still y equals 0. The amplitude changes. The period doesn't change either. Let me show you. Here's a cycle. Right. Here's from 0 to 2 pi is just a little more than 6. You see this point down here? Right. The 2 pi comma 0. So you see the red graph, one cycle. The period's 2 pi. The green graph, y equals 2 times the sine of x, still goes through one full cycle in 2 pi radians. So the period does not change when I multiply on the outside by 2. What changes is the amplitude. All right. This has the point pi over 2, 1. This has the point pi over 2, 2. All right. All the y coordinates from the red graph get doubled for the green one. And the amplitude is now 2 units instead of 1 unit. Right. Now, what if it's y equals 3? Y equals 3 sine x. Sine x. See, now the purple graph, right? Now the amplitude is 3. Same period though. Notice how the cycle starts and ends over here and then repeats. Same period of 2 pi, but the amplitude is now 3. So this number in front of the sine will help us determine the amplitude. All right. Now be careful. All right, that was multiplying by positive numbers, right? And remember, the amplitude will always be positive. If I multiply by negative numbers, the amplitude changes, but the graph flips over. So here y equals negative sine x. There, this black graph. See how, and again, hopefully this all sounds familiar from pre-calc 1. And you've probably seen some sort of graph transformations before. When you take a function and multiply on the outside, multiply it all by negative 1, it just flips the graph over the x-axis. Hopefully you're seeing that. So now instead of pi over 2, 1, the new graph has pi over 2, negative 1. Right? This multiplies all the y coordinates from the red graph by negative 1 to make the black graph. So look, same period, right? You got 0 to 2 pi here. And then the black wave repeats every 2 pi as well. Right? Goes down, then up, then down again, and starts over here at 2 pi 0. So the period doesn't change again. And the amplitude didn't change. Because what's the amplitude for the red graph? 1 unit. Same thing for the black graph. 1 unit. Again, amplitude's always positive. So the amplitude for the black graph is still 1 unit, right? From the middle line to the top or the middle line to the bottom is 1 unit. It's just you got to be careful when you multiply by a negative, that'll just flip the graph over the x-axis. It'll flip the graph over. Right? So here's y equals, negative 2 sine of x. Okay. Maybe I'll change colors on that one. Make it orange. Nah, make it purple. And get rid of this. I'll get rid of the black one. So you see the red graph is the original sine wave. The purple graph is negative 2 times the original sine function. Now again, the period doesn't change. Still have one cycle from 0 to 2 pi, and then it repeats. So the period's still 2 pi, but the amplitude is now 2. Right? I multiply by negative 2. You see from the middle to the bottom or from the middle to the top of this purple wave is 2 units. Right? So it's 3 pi over 2, 2 up there. All right. So just be careful, and I'll write that down here, and I'll write that down on my paper. All right, so when we're talking amplitude and period, and the same thing will go for cosine. So for f of x equals a times the sine of x, or f of x equals a times the cosine of x, or where a is some number that's not 0, right? I don't want to multiply by 0. That would mean nothing. So a is not 0. The period is still 2 pi. Right? The period doesn't change. The period is still 2 pi, but the amplitude is going to be, again, the absolute, it's got to be positive, so I'll say the absolute value of a, and I'll make that separate note that, if a is negative, we have a reflection across the x-axis. So I note, if a is a negative number, there will be a reflection across the x-axis, right? It flips the graph over the x-axis. So be careful. All right, now, so multiplying the sine or cosine on the outside by a number changes the amplitude. What you're going to see is that multiplying the inside by a number, say replacing x with 2x or 3x or 5x or whatever, that'll change the period. Right? And let's see how. So back to the Desmos here. So let's get rid of these. All right, this time I'll put up the cosine wave, right, just to refresh your memory as to what that looks like. There's cosine. So you see, so I'm starting from, and you know what? Let me change the window up as well. So let's have this go from 0 to 2 pi, right? The original period. Right, so 0 to 2 pi. All right. There we go. All right. So here's one cycle. One cycle, starting here at 0, 1, then going up and ending over here at 2 pi 1. Right. So here's one cycle, one period. Now, what if I replace x? So instead of y equals cosine of 1x, how about y equals the cosine of 2x? Look at the blue graph. Now this is still from 0 to 2 pi on the x-axis. See how the red graph had one cycle? It only showed up one full wave. See this blue graph has down then up one cycle of the wave and then a second cycle. So multiplying the x by 2 on the inside, replacing x with 2x, gives me 2 cycles. And you see how it's repeating every pi radians instead of every 2 pi? See how I go from 0, 1 to pi 1. There's one cycle. And then pi 1 to 2 pi 1. So now the period is pi instead of 2 pi. So replacing x with 2x cut the period in half, which is the reciprocal of 2. Cut 2 pi in half. Okay, well, how about this one? How about y equals the cosine of 4x? All right, so I'm going to get rid of the blue graph here. And look at this green one. How many times does this cycle repeat, this wave? You have 1, 2, 3, 4 of these full waves, 4 cycles in between, from 0 to 2 pi. So what the number times x gives us is called the frequency of the wave. How often does this? How many times does the cycle repeat in a period of 2 pi? Right, in a range of in an interval of 2 pi. So, and then the period, how often does it repeat? How many units does it take to repeat? Well, look, you see it starts off here at 0, 1, and then you got pi over 2, 1. Pi 1, that's another pi over 2. 3 pi over 2, 1, that's another pi over 2, and then another pi over 2. So the period is pi over 2. It repeats every pi over 2 radians on the x-axis. And that's a quarter of 2 pi. The reciprocal of this 4. All right, now you gotta be careful. What if I replace x, what if I multiply the x by a negative number? Well, all that's going to do is flip it over the y-axis. All right. Which, because cosine is an even function, won't do anything. But if I had sines up again, let me get rid of these. If I had sine up again, there's y equals sine x, and replace, say y equals, the sine of negative x. Remember that flips it. Now I know it looks like a flip over the x-axis, but replacing x with a negative times x inside the function, if you recall back from pre-calc 1, hopefully algebra, right, that will cause a reflection across the y-axis. Right. But notice, multiplying by -1 does not change the period. Right? 2 pi divided by 1 is still 2 pi. But multiplying by -2, y equals the sine of -2x. Again, get rid of the red graph. So again, see it's flipped. Right? Technically, again, flipped over the y-axis because there's a negative inside. And the period is now 2 pi divided by 2. 2 pi divided by 2, the period is pi. And you see how it starts off here at 0, 0, then pi 0, right? You get a full cycle, a full sine wave here in pi units, and then a repeat, and then it repeats. So it repeats every pi units. Right. So here's how. So the period, how often it repeats, is affected by a multiple of the inside, or a number times the x, a number times the input on the inside. All right, so I'll state that on some paper. So now we're looking at, say, for f of x equals the sine of bx, right, where this number b is on the inside, being multiplied by the x. Or, same thing for the cosine of bx. Right. I guess I'll throw the a in front as well. Might as well keep adding to this. Right? So if we look at functions like this, some number on the outside, that'll affect the amplitude, and then some number multiplied by x on the inside, that'll affect the period. Right? And the period, how often the graph will repeat. Remember how it was working? It was the reciprocal of this number times 2 pi. Or basically 2 pi divided by, and again, I want it to be the period should be a positive value. So if this is negative, I'm just going to make it positive by saying absolute value of b here. The period will be 2 pi divided by the absolute value of b. That's how often the new graph will repeat, the transformed graph. And then the amplitude I've already mentioned, right? If there's this number multiplied by the sine or cosine on the outside, that will affect the amplitude. And again, the amplitude is the absolute value of a. All right, and then some notes here. And about b, if b is negative, right, if this number times x inside is negative, there will be a reflection across the y-axis, a horizontal reflection at some point. Right? There will be a reflection across the y-axis. And I've already brought this up. If the number outside that you're multiplying on the outside is negative, if a is negative, there will be a reflection across the x-axis. Okay. All right. So now that we've seen how the period and amplitude are affected, let me get back into the assignment on that objective. All right. All right. So this first question here is just simply asking, what is the amplitude and period of the function shown below? Actually, you know, I should have brought this up as well. I apologize. Another way to calculate amplitude, you know, because sometimes, you know, the midline is not always the x-axis. We'll see later the graphs will be moved up and down as well. So another way to calculate amplitude, if you're looking at a graph like in the problem I'm looking at right now, another way to calculate amplitude is to take the maximum value, the highest point on the wave, minus the smallest value, the minimum value. All right, and this is going to be the distance from the top to the bottom, and then just cut that in half, and that'll give you the distance from the middle to the top or the middle to the bottom. So, you know, cut that in half. All right, so this is if you're looking at a graph and you can't tell where the middle line is, you know, because again, the middle line is not always the x-axis. Here's a way you can determine the amplitude. All right, so that's what I'll use back here. Because here we're seeing now the middle line is not the x-axis. The middle line is actually at -1. I don't know if again, it's not hard. It's not hard to tell, but maybe you can't. So if I'm determining the amplitude, you know, what's the highest value? 5. Right? The highest value is 5. What's the lowest value? It's -7. And how far apart are these? What's 5 minus -7? That's 5 plus 7. That's 12. These are 12 units apart. All right, so it's 12 units from the top to the bottom, meaning that it's 6 units from the middle to the top or the middle to the bottom. Right? That's why I can tell that the middle line is at -1, because that is 6 units from the top, 6 units from the bottom. So the amplitude here, doing that max minus min, then divided by 2, is 6 units. And then what's the period? So yeah, I'll start at some point on this graph and say, you know, how many units does it take to repeat? So if I just start at the y-axis here, see at 0, -1, go up, down. Now this also is at -1, but this next part doesn't repeat the first part. I'm going till it repeats. I'm going till it starts over. So from 0, -1, I follow the wave. And then we're back at -1 here. And then you see after x equals 3, the graph would repeat itself. It's going up, then down, then up. And then again, up, then down, then up. So you see how it's repeating every 3 units, right? From x equals 0 to x equals 3. So the period is +3. Again, period and amplitude should be positive quantities. All right, so that's all for that one. And then they tell you amplitude and all that, and period. Okay. All right, so this next one, another period and amplitude problem. So which of these shows the graph of, you know, f of x equals -½ times the cosine of 1/3 x? And I'll actually draw this. All right, I'm gonna pull this up on paper, and we'll draw it and talk about, you know, the amplitude and the period. So I'm given f of x equals, negative 1/2, right? That's a negative number on the outside there. So there's going to be some sort of flip times the cosine of 1/3 x. 1/3 x. Okay. So let me show you how I like to graph things like this. So first, and I'll do this a lot, first I take the expression inside the trig function. I set that equal to 0 and solve. All right. So you'll see why I'm doing this. So I take 1/3 x. I set this equal to 0. I solve it for x. That's x. X would just be 0. And this is where I'll start my graph. So I'll start graphing here. All right, I'll start graphing at x equals 0. All right. Then I determine the period. Now the period, so maybe I'll put some step numbers to this. So first step, I determine when is for what value of x is the expression inside the trig function going to be equal to 0, and that's where I'll start my graph. Step 2, I'll determine the period. Now remember, it's affected by the number multiplied by x. Remember, it's going to be 2 pi divided by that 1/3. But remember, dividing by a number is the same thing as multiplying by the reciprocal. So 2 pi divided by 1/3 is the same thing as 2 pi times 3. That'd be 6 pi. So when I go to graph this, this is how far. This is how long it's going to be before it starts repeating itself. Right? So I'll start graphing at x equals 0, and then I take this and I take the 6 pi and I'm going to add to where I start. This is part 3. Now that gives me x equals 0 plus 6 pi, or x equals 6 pi. This is where I'm going to end my graph. Now the graph doesn't end, right? Remember, the graphs of these waves go on forever and ever. But this is where I'm going to end my first cycle. I'm going to end my graph here. Okay, so I'll start drawing this up. Right. So here we go. We got the xy plane. I'm starting the graph at x equals 0, so I'll mark that off. I'm going to end it. End my first cycle, right? Again, the graph goes on forever in both directions, but what I'm going to do is I'm going to draw it from 0 to 6 pi, right? 0 plus the period. So let's say 6 pi is over there. I'm going to start my first cycle here and end my first cycle here. Now, the next part, I guess step 4, I'm going to find a quarter of the period. 1/4 of the period. All right, so that would be a quarter of 6 pi, which is 6 pi over 4. That's 3 pi over 2. This 3 pi over 2. This is going to be the distance between every notch. I'm going to break my cycle up into 3 pi over 2. I'm going to plot a point for every 3 pi over 2 on my graph. All right. So on the graph, all I did was I took the period here, this length, this 6 pi, and cut it into quarters. Right? So I cut it in half, cut each half in half. That's quarters. And then a quarter of 6 pi is 3 pi over 2. So this is 3 pi over 2 then. And then this is another 3 pi over 2, so 6 pi over 2, which would be 3 pi. And then another 3 pi over 2, which would be 9 pi over 2, right? And then another 3 pi over 2, which would be 12 pi over 2, or 6 pi. So you see what happened there? I just kept adding at my starting point, x equals 0, right, where I say I start in the graph. I go every 3 pi over 2 until I get a length of 1 period, right, until I get a length of 6 pi. And then I just plug these values in. Right, then I just plug these values in to my function. Right, so I guess this is step 5, and then graph. Right, so step 5, you should have 5 key, what I'm calling key values. Plug these 5 key values into the function, and we'll plot points, right, and graph. Right. So I'll write the function up again. We had f of x equals negative 1/2 times the cosine of 1/3 x, and I'll make a little chart here maybe, right? X and then f of x, and go and put these 5 values in: 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. Right? And the reason I'm putting these, the reason I did a quarter of the period, these values will be very nice when I plug them in, and you'll see that here. Right? So when x equals 0, I'm going to get, the output is negative 1/2 times the cosine of 0. Right? 1/3 of 0 is 0. But what's the cosine of 0? Remember, that was 1. So the output is negative 1/2 when the input is 0. Then when I plug in 3 pi over 2, you get negative 1/2 times the cosine. Now this is 1/3 of x. What's 1/3 of 3 pi over 2? That would just be pi over 2. And what's the cosine of pi over 2? That's 0. So this is negative 1/2 times 0, or just 0. So I get an output of 0. I'll plot that point. All right. Then when I plug in 3 pi, you get negative 1/2 times the cosine. What's 1/3 of 3 pi? That's just pi. And what was the cosine of pi? That was negative 1. So this is negative 1/2 times negative 1. That's positive 1/2. And then I plug in 9 pi over 2. All right, what's 1/3 of 9 pi over 2? That'd be 3 pi over 2. So I'd have negative 1/2 times the cosine of 3 pi over 2. And what's the cosine of 3 pi over 2? That would be 0 again. So this is 0, a negative 1/2 times 0. And finally, if we said earlier the period was 6 pi. These are 6 pi apart. If this is truly the period, then this last output in the table I created should be the same as the first one. Let's see. Plug in 6 pi. What's 1/3 of 6 pi? That's 2 pi. So I have negative 1/2 times the cosine of 2 pi. The cosine of 2 pi is the same as the cosine of 0. Right? That's positive 1. So this is negative 1/2. As I said it should be. The value at the end of this chart I made, right, since they are 1 period apart, should be the same as the value at the beginning. And then I'll plot these points. Right? Now I'm doing the graphing part. So we have 0, negative 1/2. Right? So let's say negative 1/2 is here, and there's a point. Right? So the 0, negative 1/2. 3 pi over 2, 0. Right? So on the x-axis. 3 pi, positive 1/2. Right? So let's say there's positive 1/2. 9 pi over 2, 0, and 6 pi, negative 1/2. And remembering that it is a cosine function, it's one of these sinusoidal functions, I draw in, it's a wave. Right? This is a wave, and it's one cycle. Right? And then I could repeat this. Right? This picture will just keep being repeated over and over and over again, going this way and going that way. So if I wanted to, I could, from 6 pi to 12 pi, draw the same picture. And from 0 to negative 6 pi, draw the same picture. All right. So there's a picture of the negative half times the cosine of 1/3 x. Now, we've already said the period is 6 pi. Right? The amplitude, or the highest value, is a half. The lowest value is negative half. That's 1 unit apart. Cut that in half, that's a half, right? And again, from the middle to the top is a half, from the middle to the bottom. It's very easy to see that the midline here was the x-axis. All right, so keeping this in mind and going back to the website, which of these is following that? So it started off at 0, negative 1/2. So maybe that one. Yeah, maybe this one too. And the period was 6 pi, so it doesn't start, 0, negative 1/2. And it doesn't get back down there till 6 pi. This one, right here, this starts off 0, negative 1/2, and doesn't start repeating again until 6 pi, which is like my drawing. All right, so that's the only one that seems to match the particular picture we're given. All right. Okay. So yeah, the way I did the graph just now is the way I'm going to do every single graph I show you on paper. Right. Same steps and everything. Alright, so this one is determining the phase shift and vertical shift. This is where numbers are being added or subtracted instead of multiplied. Alright, so I'll talk about those. Alright, so the phase shift, I'm going to go to the Desmos site here and show you some examples of phase shift and vertical shift. Now, phase shift is just a horizontal shift, and vertical shift is vertical, up, down. Phase shift is the left-right shift. Alright, why it's called phase shift, I honestly don't know. But think of phase shift as horizontal shift, right? So we go to the Desmos site here. Let me get rid of this. And we'll bring back, here was our sine graph. And let's just zoom this out a bit. Alright, so there's the sine wave. Okay. Now, first I'm going to talk about vertical shifts. Anything done vertically, like you saw how the change of amplitude, that's a vertical stretch or a vertical compression, depending on what you're multiplying by. A vertical shift, like a vertical stretch, will be something done to the outside of the function. So right now you see I have y equals, just the sine of x. There's a sine wave there. If I go y equals the sine of x, and then outside of that I add something, say I add 3. See, look what happened. The graph moved up 3 units. You see on the original sine wave there's 0, 0. Now on this new sine wave, it has the exact same shape, right? The shape doesn't change. But it moved up from 0, 0 here to 0, 3. This is the point pi over 2, 1. This is the point pi over 2, 4. Right? Got the y coordinates got increased by 3. But instead of, say, adding 3, I subtract, 5. And now look, right now the original sine wave's the black graph, and subtracting 5 on the outside moves it down 5. Pardon me. Okay. So on a paper here, I'll describe this. So you have phase shift, right? Again, this is your left-right motion. Vertical shift is your up-down motion. So if we have f of x equals the sine of x, say plus some number d. You're going to see a capital D written in the KnewtonAlta stuff. Or the cosine, same thing, or any of the waves, any of the sinusoidal functions, plus d. This will vertically shift the original graphs. If d is positive, up d units. And if d is negative, right, like I have with the -5, you'll be shifting down, the absolute value of d units. Again, down a positive number of units. And this also helps you give you that midline, right? Remember the middle line that was mentioned way earlier? So if there's this plus d after the sine and the cosine, then the middle line will be at y equals d. All right. So again, back to the Desmos site here. See, for the first one, y equals 0, right? The x-axis is the midline. And for this one here with the y equals the sine of x minus 5, y equals -5 is the midline. This is y equals d, right? That constant that's getting added after the function. All right, now I want to talk about some horizontal shifts or phase shifts. All right. Now the phase shift, here's again the original y equals sine of x. The phase shift, to determine horizontal shift is pretty simple. It's a little trickier than vertical shift. Right? Determining the vertical shift is pretty simple. But if I said, put in the sine of x and then -1, x minus 1. Again, anything horizontal, any transformation that's a horizontal is done to the inside of the function. I'm replacing x with x minus 1, inside the sine. So you see it's not moved down 1, right? If I had -1 outside, it would have been moved down 1. It got moved to the right 1 unit. You see there's 0, 0. And on this new graph, it has the point 1, 0. Do you see the shift to the right 1 unit? So if you subtract a number from the x, you're moving to the right. If you add a number, add a positive number, you'd move to the left, right? So let me see if I change this -1 here to a +1. See, now the red graph is left 1 unit. Right? The original sine x had 0, 0. This new sine of x plus 1 has -1, 0. See, it's left 1 unit. But the thing is, though, what if I combine this? All right, what if I combine this with a number times x as well, right? You're not always going to see just x plus something, x minus something. You might see 3x plus something, 4x minus something. So what if I have something like that? Let me get rid of that. So y equals, say, the sine of, now I go 2x and then with a -4. 2x minus 4. Now remember, the multiplying x by 2 changes the period from 2 pi to pi, right? It cuts it in half. So this blue graph here has a period of pi. But then how much got shifted? It got shifted to the right 2 units. and let me show you, like, this is equivalent to y equals the sine of 2 times the quantity x minus 2, right? If I were to factor, so you see when I have 2x minus 4, that's really the same as 2 times the quantity x minus 2, and you see there's an x minus 2 here. And I told you earlier, when you subtract a number from the x on the inside, that's a movement to the right. So there'd be a shift to the right here of 2 units. They would say the phase shift was 2 units to the right. Right. Now, a way I like to think about this is just taking the expression inside, and you saw me do this earlier. Taking the expression inside the trig function and setting it equal to 0 and solving. Alright, if I take 2x minus 4, if I set that equal to 0 and solve for x, x would be equal to 2, positive 2, telling me, 2 units to the right. Where is positive 2 compared to 0 on the x-axis? It's 2 units right. So that's how I determine phase shift. Right. So back on the paper here. To determine this horizontal shift, we'll have y equals, the sine of bx plus c, right, where all this stuff is happening inside here. Again, you can think of this as the sine of b times the quantity x plus c over b, right, if you did a little factoring. And I like to say, hey, when is this equal to 0? All right, this equals 0 when x equals negative c over b. Right. So that's how I like to determine phase shift. Right. So to determine phase shift, I set the expression inside equal to 0. So when is bx plus c equal to 0? And then you solve. X equals negative c over b. And if positive, it's a shift that many units to the right. If the solution to this is positive, the phase shift is that many units to the right. Is that many units to the right. Units. That many units right. If negative, right, if the solution to this equation is negative, then it's a left shift. It's that many units left. So I'll show you what I mean here with, hopefully with some examples. All right, so back to the website and back to the assignment. Now I'll go through more instruction here as well, since this is the first time we're seeing this. So they talk about the phase shift and vertical shifts of sines and cosines, these sinusoidal functions. They talk about horizontal and vertical translations here in this video. Let's get to a problem, and I'm sure there's more instruction. All right, so let's take a look at this. So which of the following answer choices correctly graphs the equation below? All right, so I'm going to put this on paper, and I'm going to graph this the exact same way I did earlier, the same steps. Right, only now I'm going to actually use the words phase shift and vertical shift. But I'm going to follow the same steps I did earlier to graph a trig function, to graph a sine or a cosine function here. Okay, so I'm graphing y equals negative 1/2 plus the cosine of x plus pi over 2. Now if you'd like, they put the constant first here. Usually I like having the trig function then the constant, so like this is the same thing as the cosine of x plus pi over 2 and then minus 1/2 after. Right, putting the constant term second. So you see that minus a half added at the end? That's going to be where the middle line is of this wave. The midline, and I mentioned this already, the midline, when I eventually end up graphing this, will be at y equals negative 1/2. And that's also the vertical shift. The vertical shift is half a unit down. We could describe it that way as well, if I want to describe the vertical shift. Is half a unit down, right? Because the negative direction on the y-axis is down. Right? So you could describe the vertical shift, but that's not what I do. All right. So again, I'll write out these steps. Right. Step 1. Now, last time I said, I take the expression inside the trig function, set it equal to 0, and solve. That's determining the phase shift. All right, so step 1 is I determine the phase shift. Okay. So again, that's where I take the expression inside the trig function. So the x plus a half of pi, right, x plus pi over 2. I set that equal to 0 and solve. Now, this is just simply require subtracting pi over 2. X equals negative pi over 2. And I mentioned this earlier, right? And again, the earlier example I did with graphing, this value right here, this is where I'm going to start my graph. I'm going to start my graph at x equals negative pi over 2 instead of x equals 0. Alright, so now if I want to describe the phase shift, remember I mentioned this on the earlier page, so I set the expression inside the trig function equal to 0, I solve. It ended up being negative. So that means that there's going to be a left shift, pi over 2 units to the left. So to describe the phase shift, to describe the horizontal shift, there is a shift of pi over 2 units. And because this ended up being negative, negative direction in the x-axis is left. Pi over 2 units to the left, right, is how I would describe the phase shift that happened here. To go from the original cosine function, just cosine x, to this one would be a shift left pi over 2 units. Alright, so that's what I start with, number 1. Next, I determine the period. How long before, how many units does it take until the graph starts repeating? So I determine the period. Remember, the period is affected by the number multiplied by x on the inside. Now here that's just a 1. Right? It's just simply x plus pi over 2 inside the cosine function. So the number times the x here is a 1. So the period is not affected, right? And remember what the period for cosine x was. That was 2 pi. This will just be 2 pi divided by 1, or just 2 pi again. All right, so the period for this new graph is the same as for the original cosine. Right? It'll be 2 pi radians divided by 1. Right? Then I take where I'm going to start my graph. Right? I take where I start my graph and I add the period to it to determine where I'm going to end my graph. Now, again, the graph goes on forever and ever in both directions. What I mean by end the graph is end my first cycle of the graph. So then I determine the end of my first cycle. Again, first cycle. You can draw more, and I will draw more for this one, right, to show you how you would graph more cycles. So I take where I start, back here when I determine the phase shift, I'm going to take where I start the graph at negative pi over 2. And I'm going to add to that the period, right, to determine where the first cycle will end. Now these have fractions, denominators, right? You have to get a common denominator. So this is negative pi over 2 plus 4 pi over 2 to get a common denominator, and then put those together as positive 3 pi over 2. All right, so x equals 3 pi over 2. All right, at this value is where I'm going to end my first cycle of the graph. Right? End the first full wave. All right, next I'm going to take, from the beginning to the end here, I'm going to break it up into quarters, right? So I'm going to take a quarter of the period. So now number 4, determine 1/4 of the period. So that's 1/4 of 2 pi. All right, so this is pi over 2. All right. This value here, I just keep adding this to the beginning of the cycle until you get to the end of the first cycle. I keep adding this to the beginning of my first cycle until I get to the end. Reach, that's a C. All right. And this will create what are called my key values. All right, I'll call these my 5 key values to the graph. So I'm going to make a little table here of some key values. So I'll have my x's, and then the value of f of x, right, or y. Same thing. Now where did I start this cycle? I said I'm going to start it at negative pi over 2. So the first value in here is negative pi over 2. And then I'm going to take that quarter period. All right, then I'm going to take this quarter period, this pi over 2, and just keep adding it until I get to the end value of that first cycle, this 3 pi over 2 that determined earlier. So plus pi over 2, 0. Plus pi over 2, pi over 2. Plus pi over 2 is 2 pi over 2, which is pi. And then plus one more pi over 2 would be 3 pi over 2. And you see that that's the end of my first cycle. So these are the 5 key values, 5 special values for this first cycle I'm going to draw. And then you plug in and graph. Right? We're going to plug these values in, and we'll get some points here, and I'll plot them, and we'll graph the function. So I plug in key values and graph. All right. So the 5 key values are listed here. What's the function? I'll rewrite the. Let's pull it up here. So here is the function that we're asked to graph. All right, this negative half plus the cosine of x plus pi over 2, or the cosine of x plus pi over 2 minus a half. All right, so the first of these key values is x equals negative pi over 2. When I plug this in for x, negative pi over 2 plus pi over 2 is 0. So I get the cosine of 0 and then minus a half. Well, remember what the cosine of 0 was. The cosine of 0 is 1. So this is 1 minus a half, and that's just a half. Alright, so when my input is negative pi over 2 for this function, the output, the y coordinate, is positive 1/2. Next key value in here, all these values that are a quarter of the period, pi over 2 apart. How about x equals 0? Well, plugging in 0 for x gives me 0 plus pi over 2 inside, So I have the cosine of pi over 2. And then you have, the minus a half. Well, what's the cosine of pi over 2? That's 0. And then minus a half is negative 1/2. All right, so input 0, output negative 1/2. The next one. And after some time, after some practice with these special values and whatnot, these key values, you should be able to do a lot of this in your head. This is taking way too long for me, but when I plug in pi over 2, now pi over 2 plus pi over 2, that's 2 pi over 2, which is just pi. So I have the cosine of pi minus a half. Now what was the cosine of pi? That was negative 1. And then negative 1 minus a half is negative 3/2, right? Negative 2/2 minus 1/2. So I'll put here negative 3/2. Then x equals, pi. And when I plug pi in for x, you get pi plus half of pi would be 1.5 pi or 3/2 pi, 3 pi over 2. Cosine of 3 pi over 2 and then minus a half. The cosine of, remember, the cosine of an odd multiple of pi over 2 is 0, and then minus a half is negative half. And then if everything was set up correctly, which it was, we said the period was 2 pi, right? From negative pi over 2 to 3 pi over 2, that's a distance of 2 pi. So the outputs should be the same since, should start repeating again after 2 pi. Well, let's see. When I plug in this last key value, this 3 pi over 2 up here, well, 3 pi over 2 plus pi over 2 would be 4 pi over 2, which is 2 pi. And then you got minus a half. Now what is the cosine of 2 pi? That's the exact same as the cosine of 0. This is 1 minus a half, which would be positive a half. Again, again, if you do everything I've been doing here, and I'll do this again, every single trig function I graph, I do this way. So if you want to follow along, great. But every single one of these tables, the value at the beginning should be the same as the value at the end. Now let's actually plot these points on some coordinate plane. Now it's not going to be perfect. I'm doing it by hand here. But here's y-axis, x-axis. I'm starting at negative pi over 2. Let's say that's over here, right? And then I'm going to go every pi over 2 for these key values. I'll mark off all my key values: 0, pi over 2, 2 pi over 2, and 3 pi over 2. So here's going to be the graph of one cycle of this cosine function. That's the whole period. Negative pi over 2 to 3 pi over 2 is a distance of 2 pi. All right, then I plug these values in, and I got these outputs. One of them was at a half. So I say positive 1/2 is up here. So there we go. Negative pi over 2 a half. 0, negative half. So I plug in 0 again, output of negative half. There's a point there. Pi over 2, when I plug that in, got negative 3/2. So there's negative 1/2, negative 2/2, negative 3/2 down there. Pi over 2, negative 3/2. Pi, negative 1/2 back here. And 3 pi over 2, positive 1/2 here. And just remember that this is supposed to be some sort of a wave form. So, like this. Right, cup down, cup up, cup down. Right. And here is one cycle of the graph of this function. Now I could add more. I could easily add more. Just keep adding on that quarter period. Remember this quarter period here, this pi over 2? Just keep adding on pi over 2. So like 3 pi over 2, do it again. Add another pi over 2. That'd be 4 pi over 2, which would be 2 pi. And then follow the other points at these key values. Got negative half, positive half. When I plug in 2, if I plug in 2 pi here, you should get negative half as an output. And I leave that to you to try it out. Add pi over 2 again. Add another one of those quarter periods. That's 4 pi over 2. Go over here. Another pi over 2 would be 5 pi over 2. Go ahead, plug in 5 pi over 2. you'll get negative 3 halves, right? Just following the wave. Right, so I could add on to this graph. Cup down, cup up. And that would continue on that way forever. Right? Remember, the domain for these cosine functions is all real numbers. I could also go in this direction. And starting from here at the beginning of my first cycle, just keep adding or subtracting that quarter period, which was pi over 2. So if I do it again, it's negative 2 pi over 2 or negative pi. And if I follow these special points at these key values, the value, when I plug in negative pi for x, the output should be negative half. Right, and I could keep doing this all day long, but I'm not going to, right? And then this, again, this would continue on that way, following this same pattern forever in both directions. So here is a graph of that particular function that was given to me. All right. And I'll state some things about it, right? We've already stated the period was 2 pi, right? That didn't get affected because the x was only multiplied by 1. The amplitude, let's put amp, is also just 1, right? There's no number in front of the cosine. You know, the distance from the middle to the top, from negative half to positive half, is 1 unit. Or from negative half to negative 3 halves is 1 unit. The domain is always going to be, for these cosine and sines, is all real numbers, right? You can plug in anything. I can plug in anything for x and get an output. Now the range, right? The range changed, right? For the original cosine, it's from negative 1 to 1. But when you do vertical shifts and stuff like that, the range now is, the lowest value is negative 3 halves. The highest value is positive 1 half. So from negative 3 halves to positive 1 half, right? And including those with brackets. Okay, and keep this picture up. Move back here, or maybe I'll just slide it. Let's see which one of these match. Now I can't really tell. Let me get rid of this actually. So scrolling down here, I want something with a period of 2 pi. Has the point negative pi over 2, positive 1 half. And so far the only one, this one has negative pi over 2, positive 1 half. And it also has 0, negative 1 half, which I had. It has pi over 2, negative 1.5, which I had. It has pi, negative half, which I had. And 3 pi over 2, positive 1 half. So like you see this one cycle here, and it's repeated. All right, this is the exact same picture I drew on my paper. Right. Yeah, but those 5 steps, right? Those 5 steps I followed, I'm going to do every single time. And if you want to follow those same steps, that'd be wonderful. All right, so same thing here. I'm going to do the same thing with this one. All right, so in the same steps, I'm graphing y equals the sine of x plus pi over 3, and then minus 1 after. So first, that phase shift, and when I solve this, I'm also going to figure out where I'm going to start my graph from. So remember how I found this. You take the expression inside the trig function, this x plus pi over 3. Set it equal to 0 and solve for x. Well, this would just simply be subtracting pi over 3. X equals negative pi over 3. All right. So like before, this is where I'm going to start the graph. I'm going to start my graph. I'm going to start the first cycle, because again, you can add more cycles on later, repeat the same graph over and over again. I'm going to start my first cycle here. This is my first key value. Now, if you were asked to describe the phase shift, I'll just write it here. This ended up being a negative number, right? So if I was looking at the original sign compared to this sign, we'd be shifting pi over 3 units to the left, right? This solution ended up being negative. Negative in the x direction is left. So this is the way I would describe the phase shift is pi over 3 units to the left, right? And if it was positive, it'd be to the right. Okay. But, all right, so first key value. Next, what's the period? Now the period of, sine of x normally is 2 pi. What's the number times the x in here? It's just 1. So the period again is not affected. Still just 2 pi. And then I took that and added it to the start of my first cycle to know what the end of the first cycle I'm going to draw is. Negative pi over 3 and then plus 2 pi. Now this is negative pi over 3. This is 6 pi over 3, right? Negative pi over 3 plus, to get a common denominator, right? 6 pi over 3 is 2 pi. So adding these together is 5 pi over 3. All right, so x equals 5 pi over 3. This value is where I'm going to be ending my first cycle, right? And if I want to draw more cycles, I can. Now, how do I create the special values to make graphing these easier? I then find a quarter of the period. Break the period up into quarters. A quarter of the period is again a quarter of 2 pi, which is just pi over 2. All right, so this quarter period is again, this is the distance between each of the key values I use for my graph. Key values in my graph. That's what the quarter period, and I'll just keep adding that quarter period. You keep adding pi over 2, pi over 2, pi over 2, pi over 2 to get more and more special values to plug in. All right, so I'll make a little chart with these key values for the first cycle. So I want to start at negative pi over 3 and end at 5 pi over 3. All right, so key values for the first cycle. I should have written that last time, I guess. Because again, you can always do this for more and more cycles. So make a little chart here, x, y. I'm starting at negative pi over 3. And then I just keep adding pi over 2. Now, they have different denominators, right? Pi over 3 and pi over 2. So you remember, when you add fractions, you need a common denominator. The least common multiple of 2 and 3 is 6. So think of this as negative 2 pi over 6. And this is 3 pi over 6, isn't it? Right? Pi over 2. So if I'm at negative 2 pi over 6, which is negative pi over 3, and I keep adding pi over 2, I keep adding 3 pi over 6. So negative 2 pi over 6 plus 3 pi over 6 would be 1 pi over 6. Then plus another 3 pi over 6 would be 4 pi over 6, which reduces to 2 pi over 3. Then 4 pi over 6 plus another 3 pi over 6 would be 7 pi over 6. And again, there should be 5 of these if you're doing this right. And then 7 pi over 6 plus another pi over 2 plus another 3 pi over 6 would be 10 pi over 6. 10 pi over 6 reduces to 5 pi over 3. And oh look, isn't that where I said right here that I was going to end my first cycle? So here's the key values for the first cycle. And then I'm going to plug these in, and we'll get some points to plot. All right, so again, I'm doing this the long way. I'm actually going to write it out. Over time, hopefully with enough practice, you'll be able to figure the outputs out without too much work in writing. So x equals negative pi over 3. Say I were to plug that in. When I plug this in, that gives me the sine of 0 and then minus 1. The sine of 0 is 0, and then minus 1 would be negative 1. Right? So the output when x is negative pi over 3 is negative 1. When x equals pi over 6, right, the next key value, plug in pi over 6 for x. Pi over 6 plus 2 pi over 6 would be 3 pi over 6, which is pi over 2. So I'd have the sine of pi over 2 after simplifying the inside, minus 1. Now the sine of pi over 2, sine of 90 degrees, is 1. Minus 1 would be 0. So the output here is 0. Then I plug in 2 pi over 3, the next key value. Now 2 pi over 3 plus 1 pi over 3 is 3 pi over 3, which is pi. So I have the sine of pi, then minus 1. Now what was the sine of pi? The sine of any multiple of pi was 0. 0 minus 1 is negative 1. Then x equals 7 pi over 6. And when I plug in now 7 pi over 6 plus 2 pi over 6, which is pi over 3, that's 9 pi over 6, which reduces to 3 pi over 2. All right, the sine of 3 pi over 2, and then minus 1. And what was the sine of 3 pi over 2? That's negative 1. And then minus 1 is negative 2. And if you did everything correctly, which I have, this value and this value are 2 pi apart, which is the period, and that's when it should start repeating. So the value at the beginning should be the same as the value at the end, negative 1. All right. So I'll start plotting these, and remember it's a sine function, so it should be a wave. All right. So let me graph this wave. Plot these points. So again, here's the xy plane. Starting at, let's say negative pi over 3 is here. And I just keep adding pi over 2, and that takes me to pi over 6. And I'm just going to, positive pi over 6 should be on the right side of 0. And now I'm just going to make sure all my notches are the same distance apart. So I try to keep it like that and that. And there's 2 pi over 3. That's another pi over 2. Right? Then another pi over 2. 7 pi over 6. Then another pi over 2. 5 pi over 3. And plugging these values in, the first gave me an output of negative 1. And there was one with negative 2 there later, but negative pi over 3 gave me an output of negative 1. Pi over 6 gave me an output of 0. 2 pi over 3 output of negative 1 again, then negative 2, then negative 1 again, and you can hopefully see the wave, right? A little cup up, a little cup down, cup opening up, and there's one cycle of that wave, and this picture would repeat over and over again as you move left and right. All right, so like I said before, if you want to keep going, just take that quarter period, right? Take that quarter period, pi over 2, and just keep adding this and following the wave. So remember, pi over 2 is 3 pi over 6. So this is 10 pi over 6. I add another pi over 2, another 3 pi over 6. It'll be 13 pi over 6 over here. Right? And the output should be, if I follow this, should be 0 at this this other key value. And then it'll keep going like that forever that way. And I could also do this over here. Negative pi over 3, this is negative 2 pi over 6, minus pi over 2, minus that quarter period. Then minus 3 pi over 6, it'll be minus 5 pi over 6. So again, let's try to do the same distance, same notches here, minus 5 pi over 6. And if I follow the wave and the values at these key values, all these values that are pi over 2 apart, a quarter of the period apart, should be negative 2 output here. And you can try it, plug in negative 5 pi over 6 for x, you'd end up with an output of negative 2. And that'll be the bottom of the wave, and then you'll keep going on that way forever. So again, it takes a while to describe it first, but again, over time, with more and more practice, should be quicker. All right. So which one of these looks like the one I just drew? So not that one, not that one. Yeah, this one. See, its highest value is 0, its lowest value is negative 2. Just a little after pi. This one looks like it's working like the picture I just drew. Not this one. The only one that looks anything like the picture I just drew is this one. Great. All right, so another one. Now this one I'm going to do the same thing again. All right. All right. So first, I'm going to take 2x, set that equal to 0. That's when x equals 0, right? So there is no phase shift. 0 units right or left, right? So if you were describing the phase shift, there is no phase shift. Right? Or you could say the phase shift is 0 units. And this is where I'm going to start my first cycle. I'll just say start. Now the period for this sine function. This time, see, there is a number other than 1 multiplied by the x in here. Remember, that affects the period. It's going to be half of 2 pi, right? It's going to be, normally the period of sine is 2 pi, but that's going to be divided by this 2. Right? So the period for this function is pi. Right? And then I'm going to add that to the start, right? X equals 0 plus pi, just pi. This is where I'm going to end the first cycle. Right? Again, just the first cycle at x equals pi. Then I break the period into quarters. Right? A quarter of the period is just pi over 4. Right? A quarter of pi. And this is huge. Right? This helps me graph the rest of the thing. Again, one more time. This is the distance on my graph between key values. Right? Very important values to help me make this graph a little easier. Right? And I'll make a table where I start at 0, end at pi, and just keep adding pi over 4 for the special values. Right, so I make a table, start at 0, and I just keep adding pi over 4 until I get to pi. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4, which is pi. Right? And again, if you're doing this correctly, the way I'm setting it up for you, should have 5 of these for the first cycle. All right, now here comes the part where I'm going to kind of breeze through and not write anything. Plug in 0. The sine of 0 is 0, so times negative 5 would still be 0. Plug in pi over 4 for x. 2 pi over 4 is pi over 2. The sine of pi over 2 is 1, but then you're multiplying by negative 5, so you get an output of negative 5. Plug in pi over 2. 2 times pi over 2 is pi. The sine of pi is 0, times negative 5 is still 0. Plug in 3 pi over 4. 2 times 3 pi over 4 would be 6 pi over 4, which reduces to 3 pi over 2. The sine of 3 pi over 2 is negative 1. Negative 1 times negative 5 is positive 5. Right? You see how quick this can be if you actually know all your values? Plug in pi, you got 2 pi. Sine of 2 pi is 0 times negative 5 would be 0. And again, if you set this up correctly, the value at the beginning and the end should be the same because they are one period apart. Right? The 0 to pi is the period apart, pi radians apart. All right, then I go to graph. So I'll start at 0 and just have every notch represent pi over 4. Alright, and then plugging these values in, I'm seeing a 5 there, and I'm seeing a negative 5, which would be on just the opposite side, and a 0. And you got 0, 0, pi over 4, negative 5, pi over 2, 0, 3 pi over 4, positive 5, and pi 0. And then cup up, cup down, right? Just follow a wave. It's a sine function. There's one cycle. All right, again, you see, and I even explained more than I felt like I should. It's very quick and easy to do it the way I've done with the key value method. Now, if you want to keep it going, again, just keep adding this quarter period to this graph. So this is pi. I keep adding pi over 4. Keep adding the quarter period. Keep adding pi over 4. So this is add another pi over 4. This would be 5 pi over 4. Then 6 pi over 4 would be 3 pi over 2. And I could put in the outputs. You can plug them in if you want and get outputs, but just follow the wave. Know that this picture is going to keep repeating. So if I follow this at 5 pi over 4, the output should be negative 5. At 3 pi over 2, it should be 0. I'd be doing this and going that way forever. And then if I wanted to, I could go left as well. Again, just take my key values and keep adding or subtracting that quarter period, which is pi over 4. So I subtract, take away pi over 4, take away another pi over 4, take away another pi over 4. And if I follow the pattern here, the output at negative pi over 4 for this function should be positive 5, and then 0 at that key value, and then negative 5 at this key value. And just keep following the wave. The picture just repeats over and over again, and going this way, that way, forever. All right, now looking at this, and you got the domain. We know is all real numbers, right? For any of these sine and cosine waves, it's all real numbers. You can plug in anything. The range looking here is -5 to 5, right? Everything from -5 to 5. We said the period already. The period was pi, right? This is repeating every pi radian. 0 to pi, pi to 2 pi would be the same picture. 0 to -pi would be the same picture. The amplitude is 5, right? From the middle to the top. Or, remember, you take the top minus the bottom. That's 10 units, and then cut it in half. Amplitude's 5. There is no phase shift. There is no vertical shift. Right? So, this is it. And I graph this in exactly the same fashion that I'm going to graph every single trig function you see. So if you like to follow along and do the things the way I'm doing them, it's going to be easy for you. Alright, now which one of these actually looks like my picture? Nope, 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 nope. This one. 0, 0, then pi over 4, right, halfway between 0 and pi over 2. They got, the amplitude is clearly 5 units. Its lowest is at -5, highest is at 5, has 0, 0, goes down, then up, then down, then up, then down, then up. That's exactly like I drew. Wonderful. All right, this one they're just having you look at a graph and state the amplitude and period again. Highest value is 3. The lowest value is -7. That's 10 units apart. So I'll cut that in half. That's 5. This has an amplitude of 5 units. Right. So the middle would be at -2, right? Because -2 to 3 is 5 units, and -2 to -7 is 5 units. So -2 is the middle line. Y equals -2, and then the period is, again, how often does the graph repeat itself? How long until it repeats itself? So if I start here, you got 0, -2, and it goes up, then down, then there. I'm back at -2 here at 6. So from 0 to 6, and then it starts repeating again. So this has a period of 6 units. Hopefully that makes sense. All right, we're almost done here. All right, this one, it's all right, so graphing this, I'm going to tell you right now, this will have the point pi over 3, comma, -5. Pi over 3 is about 60 degrees, so not that one. No, no. Thinking this one. Yeah, so that's the only one that would have pi. That's the only one that has the point pi over 3 and -5. Again, you can go through the same steps I went through. I just feel like I've shown you enough in this video. I'll be doing the same steps again in a future video on other trig functions as well. So if you didn't follow them here, either rewatch this video or wait till the future ones, and you'll see it. You'll see the procedure I went through for those key values again. And one more here. So this is going to have the point 5 pi over 6, -3. And that'll be the highest point. Now 5 pi over 6 is a little less than pi. So something a little less than pi and -3. So not that one. A little less than pi, -3. And it looks like this one. Yeah, and this looks like the cosine. So I'm going to say this one for now. Nope. 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 Alright, so it's this one here with 5 pi over 6, -3. Oh, no, the one with -3 is at the top there. It's at the top of a hill. So this graph. Now again, you can do it, go through the procedure I went through, those 5 steps, make a graph with the key values, and you'll see a graph looking like this when you draw it. Like I said, I'll do much more like that in the future. You'll see that me doing the same procedure every single time. Every single time I go through the same exact steps. So if they're not making sense to you now, hopefully they will in the future after you see me do a bunch more. Alright, so hopefully this was a good guide for you to help you when you work on the section 8.1 part 2 on your own. And if you have any questions, of course, let me know. Thank you very much for watching.